Instead of creating electricity, the generators will act like brakes, slowing or stopping the spin of the turbine and causing it to fail. Fred hopes the generators will move into the right position when the turbine is full of helium. But 1 hour later, they're still not right.
The netting's holding the blades in place, but we need to get that netting in the right position such that those metal plates are dead in line with the centres of the end of the balloon.
The friction between the end discs and the turbine is now so great that realigning the generators by hand is impossible.
We're never going to fight the forces of friction. We've got to let it up into the air and get it rotating. If we keep on turning it manually, it might centre itself. Let's give him a hand spinning it.
It's working. The generators are lining up at the ends of the turbine.
That's really close. We're getting there, boys.
It looks terrific.
The other end's still off about that far, but it's so much better than it was.
Yeah, Fred, it's so close, but so far. That's what I hate about this.
The problems have delayed inflation, and now bad weather is closing in.
I think we've gone through a really steep learning curve today, and we've faced a few challenges, but I'm confident. Leave it for the night. Tomorrow morning, nice and early, we inflate it, give it some twists, and it's going to self-center itself.
The team decide to abandon the experiment until the morning. They arrive early the next day, eager to get to work inflating the balloon to full capacity.
What do we have to do today to get this thing up in the air and test it? What's left to do?
Well, pressurize it up, inflate the torus rings, and then get everybody out here in the crew to start manning the lines.
Jennifer and Basil prepare to inflate the central fin with compressed air. When it's fully pressurized, the cylindrical ring should add stability during flight.
Because it's air and it's air under pressure, it provides some centrifugal forces or gyroscopic forces, the same as you get when you fling a frisbee. A frisbee doesn't fly because it's flat, it flies because it's spinning. And of course, this is a spinning design. So as it spins, we get a little bit of frisbee effect from that center ring, which is a stabilizing effect.
The turbine is fully inflated. The pressurized helium can now lift 900 kilos. The team get ready to deploy. First, they secure the 90-meter Vectron tether to the winch truck. Electrical monitors are checked. And a radio-linked anemometer is attached to the truss to measure wind speed. As they pay out the mooring lines, the prototype begins to rise. 18 meters above the ground, the main tether takes the strain without a problem.
Looks promising, Fred. Very promising.
But before the balloon reaches its target altitude, Basil spots a problem.
See what it's doing now? It's a low-frequency flutter, just like it was doing in the wind tunnel.
Is it doing a figure-8 flutter?
It's
Oh,
going
yeah,
like that.
there it goes.
I'm not concerned at the moment. Once we get up, the wind is steadier, and therefore the whole device will become steadier. And that's what we're looking for next.
Fred suspects it's some temporary ground turbulence, and the airship will stabilize higher up. He's right. As the balloon ascends, the swaying stops. But are the generators centered enough to let the turbine rotate? The wind's picking up. It's the moment of truth.
Come on!
Looking good, Baz, looking good. This is it.
We're at 10 miles per hour.
Come on!
Come on, come on. Oh, come on!
You see those fins bulging out, catching wind? Come on!
Spin. Oh, it's going!
There we go!
It's definitely rotating.
Come on! Come on! Come on! All right!
But what looks like success is short-lived. When the wind drops to 18 kilometers an hour, the turbine stops turning.
I can see wind there, and this thing should work.
What worries the team the most is that the turbine has failed after extensive wind tunnel tests and computer models.
I'm beginning to think this is a prototype with a lot of design flaws in it. The implementation requires some work.
You know, the Wright brothers didn't go very far in their first aircraft, and yet today we fly in 747s.
In a quiet mountain clearing, the dream of freeing the world from fossil fuels has stalled. But like those two pioneers at Kitty Hawk, Fred is determined to fight on and get it right. 2 weeks later, time is up. Basil heads to Fred's test site in Virginia, hoping the airship designer has overcome failure one more time.
Hey, Basil, good to see you.
So when I left you last time, this thing wasn't turning very well. Can you take me through what you've done to rectify the problems with the turbine?
In a nutshell, we've tightened everything up so that we get around that bending effect that we were worried about. In doing so, everything will line itself up nicely, and it should rotate easily now at very low wind speed.
Originally, ropes connected the generators to the metal truss that supports the turbine. Fred's replaced the ropes with steel rods, and the results look encouraging. Instead of sagging at the ends like it did in the previous test, the turbine now holds its shape as it inflates.
What about the blades? Have you changed them at all?
We've loosened the blades up.
2 weeks ago, the turbine barely rotated in the wind. To fix the problem, Fred's increased the size of the chevron blades, so their greater surface area can catch more wind.
So you've made quite a few improvements to increase its efficiency, get it turning in the air. I'm really looking forward to seeing this work now.
Yeah, me too.
At 11:31 a.m., the aerial turbine is 90 meters overhead. The winds are only 16 kilometers an hour. For Basil and Fred, what's unspoken now, but fresh in their minds, is the chance of another unpredictable lurking somewhere in the system.
That is so much better.
Then the failures of the past begin to blow away.
So good.
We did it.
What a result.
The turbine's rotating, even in low winds.
How are we looking, Bruno?
Hey, we're getting some power out of it.
Look at that.
Watch out, it's going to break.
Whoa! We're generating 200 watts.
Hey, good stuff. Hey, good stuff there, Bruno. Jeez.
Thank you.
A really great day. This is exactly what I was hoping we'd get to. We know we have a proof of concept that will work. It has some problems, but they're not big, and they're correctable. So as we move forward over the next few months, you're going to see something really big and really great up in the air.
The test proves that new technology can capture energy from reliable winds aloft. Fred believes skies filled with aerial turbines could help end our dependence on fossil fuels to generate electricity. But is this really a practical way to reduce the world's CO2 emissions and slow global warming? The design works, but there are many questions yet to be answered.
Tudo pode mudar em alguns segundos. Uma decisão tomada num instante pode salvar uma vida ou destruir um sonho.